Alright class, today we're going to start with trig identities. Now, I would recommend you pause the screen right now and write all this down. Okay, hopefully you paused. I'm going to talk quickly about it. You should remember your reciprocal identities, and you do need to remember those. Okay? These next ones in red, green, blue here are called our Pythagorean identities, and they all stem from the unit circle using Pythagorean theorem on a unit circle saying that sine squared plus cosine squared equals 1. Then you can get these other two by dividing by either sine squared or cosine squared. You do not need to do that. I'm just telling you how they showed up. So these are also trig identities that go with this one. These other ones over here in parentheses are the same identity, just moved around. All I did was subtract cosine squared on this one, or I subtract sine squared on this one. You should be able to do that on your own. I will give you these three over here on the left though, but in the ones in parentheses you need to know how to do on your own. So we're going to have to use those to replace things in our identities. And what an identity is, we're going to try to prove one side equals another. So some tips before we begin, and again you might want to pause here before we go on. Only work the more complex side because it's easier to simplify something down than expand. You guys are more used to doing that. Look for your Pythagorean identities, look for substitutions for them. If you're stuck, sometimes it's easier to change everything to sine and cosine. Also, you want to get common denominators so you can add fractions together. Alright, so let's look at the first one over here. So we're going to verify the following identity, number 1. So I want to show that this side equals this side. So clearly I want to work this side because it's more complex. So the first thing I noticed is that sine of theta, this is actually 1 over sine of theta. So when they do this, sine over sine is 1. So I get 1 minus cosine squared theta. So now I see that I have a trig squared. Usually with trig squared you want to look and see if there's a Pythagorean identity. Well, sure enough, if you look at the top of your page, sine squared plus cosine squared equals 1, which means 1 minus cosine squared is sine squared theta. And we proved it. Okay? Because this is an identity to get to there. Alright, and that's all you have to do. Number 2, same thing, you want to work the more complex side. Clearly that's the left side. So I see I have a cosine, a secant, a cotangent, and a sine. Now if you see right away that these are reciprocals of each other, you know cosine and secant are reciprocals, that just turns into a 1. Then this turns into a cosine over a sine, and this is times sine. So sure enough, the sines cancel, and I'm left with cosine of theta. So sometimes it's as simple as just simplifying the one side, and there's not as much work to do. So, alright, let's move on then. Okay, again I'm going to work the left side, because again there's a lot more going on. I look ahead, I don't see any trig identities because there are no, I don't see any Pythagorean identities because there's no squareds. So I don't see much else except for that there's a tangent. So when I see a tangent, I'm going to try to change that into sines and cosines. So I have cosine of theta plus sine of theta times sine of theta over cosine of theta. So I get cosine of theta plus sine squared theta over cosine of theta. So that's the only thing I can do right now. When you see something like this and you have a fraction, the next step is always to get a common denominator. Since this one has a cosine on the bottom, I want to multiply the top over here by cosine over cosine. The left side. So we end up with cosine squared theta plus sine squared theta all over cosine. Okay. Now, at this stage I have things being squared now, so I'm going to look at my identities, and sure enough, sine squared plus cosine squared, the first one I gave you, is just 1. And 1 over cosine is secant. And we did it. Okay. This next one will be tricky to figure out. Let's look at it real quickly. I see tangent squares and secant squares, which is good because I know that I have an identity that deals with those, my Pythagorean identities. I have to figure out what side to work. It looks like it's more complex on the left because there's secant squared and tangent squared. So the next thing you want to do, there's two things you can do. You can rewrite them as sines and cosines, combine them and split them, or look for your Pythagorean identities first. Notice how there's no tangent squared over here, but there's a tangent squared here. There is something I can sub in for tangent squared because of my Pythagorean identities. So that would probably be the thing I would do first, is figure out what tangent squared is equal to. And if you look at your identity, it's 1 plus tangent squared equals secant squared. So if you solve for tangent squared, it's secant squared minus 1. So I subbed in for tangent squared its identity. Now I can, looks like the only thing I can really do is distribute that 5. So let's see what happens. Or negative 5, I should say. Okay, so I have a 5, which I need, and what's 9 secant squared minus 5 secant squared? It is 4 secant squared. So actually that one turned out to be nice. But again, it's only nice if you know how to do it. So that's why we're doing these. We're just talking about different things you can see and look for in your identities. Okay, let's do the next one. Number 5, obviously I'm going to work the left side because the right side I wouldn't know where to begin. It's just cosine. The only thing I really can see to do here, when I see something like this, I have a tendency to want to FOIL it, personally, so I would do that. So I get secant theta plus secant theta sine theta minus tangent theta minus tangent theta sine theta. Okay. That doesn't help me much, but I have a lot of secants and tangents and sines. So when I have all that and there's no squareds, I have to turn everything into sines and cosines. So I have a 1 over cosine plus sine, and this will become over cosine. Or you could think about it as multiplying by 1 over cosine, but I'm just going to do that. Minus sine over cosine, because that's what tangent is. Oh, that's going to help. Minus sine times sine, which is sine squared theta over cosine theta. Okay. So the good news is everything has a common denominator of cosine. The other good news is this fraction and this fraction cancel out. So I'm left with a common denominator of cosine on the bottom, and the top becomes 1 minus sine squared. Alright, now that I got here, I noticed that I have a sine squared. So I can do an identity. 1 minus sine squared is cosine squared. And sure enough, one of them will cancel on top with the one on the bottom, and we're left with just cosine of theta. Alright, so that one is a little bit more challenging just because there's a lot to do, but again, it's all algebra. You just have to try to simplify it down as much as you can. Alright, last one we're looking at. Again, I would probably... Oh, this one's actually really quick if you can see it. I'd work the left side. Hopefully you guys are starting to recognize what's true about cosecant and sine. Hopefully you recognize that those are reciprocals. So if they're reciprocals, when you multiply them, you get a 1. And then again, what is 1 minus cosine squared? We just, well, we did the opposite of it, but it's the same thing. It's sine squared. So we end on an easy one. So that's how you do identities. You basically pick a side. You do not move things to other sides. You only work on the one side. And then try to get it to look like the other side. Again, it's not, there's no one way to do them. That's what makes this challenging. You got to just work through them, practice, see what you can do. You know, there's many different ways to go. And yeah, don't get frustrated. All right, I'll see you next time.